Let's kick things off with a hard clinical number, $1,420. If you're still buying into that influencer-driven magic wand hype, the idea that web scraping is just pointing a basic script at a URL and watching clean data magically drop into your database for pennies, well, you're setting yourself up for a pretty catastrophic wake-up call. So what actually happens when an unoptimized scraping run slams into modern web defenses? I'll tell you. A simple $15 job silently and aggressively morphs into a $1,420 invoice, all before you've even extracted a single usable data point. Welcome to the truth of tech. In this explainer, we're taking a deep, zero-hype look at the architectural and economic realities of modern AI web scraping. We're going to cut right through the noise and break down pipelines built on extraction APIs like Firecrawl and large language models like Claude 3.5 Sonnet. Let's be real, the old vending machine era of web scraping, it's completely dead. Replacing it requires an absolute masterclass in both infrastructure and cognitive AI management. To respect your time, here's our exact system boot sequence. First, the $1,420 API invoice risk. Second, the credit multiplier trap. Third, optimized Python pipeline architecture. Fourth, unit economics. And finally, a deployment blueprint. Let's dive in. Chapter 1, the $1,420 invoice risk. Right now, the biggest infrastructural threat facing any data engineer is literally going bankrupt before your engine even gets off the ground. Picture this. A developer writes a script to scrape, say, 1,000 protected B2B profiles. They budget 1,000 API credits. Sounds totally reasonable, right? But modern targets aren't just simple web pages anymore. They're digital fortresses. If your target site dynamically ramps up its Cloudflare defenses mid-scrape, your extraction API gets trapped in a challenge loop. It's repeatedly trying and failing to bypass bot detection, burning credits on every single attempt. Suddenly, crawling just 1,000 pages burns through 25,000 credits. You wake up the next morning and that simple overnight job? Yeah, it just handed you a $1,420 invoice. Chapter 2, the Credit Multiplier Trap. To understand how an invoice gets that massive, we've got to look at the physical reality of the modern web. In the good old days, you'd send a request and just get an HTML document back. Easy. Today, modern B2B directories are incredibly complex, single-page applications built on React or Next.js. The data you actually want isn't even in that initial HTML response. The page is functionally empty. To even see the data, your API has to spin up a headless browser instance in the cloud. You're literally renting a hidden version of Chrome just to execute the JavaScript and render the DOM. And this brings us to the precise mechanics of the credit multiplier trap. You see, providers don't just charge a flat fee anymore. They bill based on the compute required to penetrate the target. A static HTML request, that's a 1x multiplier. But the second you need that headless browser for JavaScript rendering, boom, you're hit with a 5x multiplier. And here's the truly devastating part. When you hit enterprise-grade defenses like Cloudflare, the API has to route your request through residential proxies. This means it tunnels through a real home IP address to mimic human behavior. That survival mechanism triggers a massive 25x multiplier toll. Don't get me wrong, bypassing anti-bot defenses is brilliant engineering, but man, is it incredibly expensive. Chapter 3, Optimized Python Pipeline Architecture. So how exactly do we fix this? Well, here we have a production-ready Firecrawl Python implementation. Look closely at the parameters. We're passing formats, Markdown, and only main content true. By doing this, we're deliberately instructing the API to strip away the thousands of lines of raw HTML, inline CSS, and those chaotic tracking scripts on the back end long before the AI ever even sees it. This drastically drops token bloat, lowering your overall compute cost. But honestly, just as importantly, it acts as a vital epistemological filter. By delivering clean Markdown, you're curating the reality the LLM sees. You're completely removing the noise that causes cognitive overload. Now, curating the input is great, but it's not enough on its own. We still have to address what I call the eager intern problem. Think about it. You're applying deterministic pressure to a probabilistic engine. An LLM is fundamentally designed to be helpful. So if you feed it a clean page, but the target company simply forgot to list their email address on that specific profile, the field is natively blank. The model looks at your rigid schema demanding an email, and like an eager intern who's just desperate to please you, it'll hallucinate. It will confidently output a syntactically valid but entirely fake placeholder, like johndoe@placeholder.com. This brings us to a crucial point. A perfectly cost-optimized pipeline that successfully bypasses Cloudflare but extracts entirely fake emails is frankly completely useless. Actually, scratch that, it's worse than useless. It actively damages your business. Imagine those fake emails getting pushed into your CRM.
Your sales team starts running automated campaigns to non-existent addresses, which triggers spam filters, and before you know it, you've completely destroyed your domain reputation. A trust deficit with your own data is way more toxic than a hefty infrastructure invoice.
This is exactly where we implement Anthropic tool use, which is also known as structured outputs. We use the neural network to bridge the gap in structural fragility because it semantically understands what an email is, no matter how the page layout changes. But, and this is key, we bind it to a deterministic schema. We define the exact JSON keys required, ensuring the LLM knows precisely what shape the data must take. No exceptions.
But hey, the schema alone isn't enough either. The system prompt is your absolute final line of defense. Take a look at these aggressive guardrails. We explicitly command the model, extract only if explicitly printed, never guess. We demand that if a field is missing, it must output the exact string not found. By doing this, we're fundamentally transforming the AI from a creative, generative writer into a cold, clinical, rule-bound extraction engine. We're isolating its semantic parsing ability while ruthlessly suppressing its creativity.
Chapter 4. The Unit Economics Compared. All right, now that we've mapped out this dual architecture, let's look at the hard data. If you rely on an unoptimized setup, pulling raw HTML, getting trapped in endless JavaScript rendering loops, and suffering those brutal 25x residential proxy multipliers, your unit economics simply will not scale. You're guaranteeing yourself an unsustainable cost of $93 per 1,000 extracted pages. Building a system on this foundation is essentially building a machine specifically designed to burn your budget. But when we apply the optimized architecture, the contrast is absolutely staggering. By enforcing back-end Markdown conversion, limiting wait times, and using strict prompt guardrails, we drop the compute and token costs drastically. We're talking about an 83% cost reduction. That brings the unit cost down to a highly controlled $15.50 per 1,000 profiles, with a near zero risk of hallucinated data. For sure, this is how you actually achieve financial sustainability. Chapter 5, Final Verdict and Deployment Blueprint. The modern web requires some highly sophisticated orchestration. But for you, technical founders and data engineers ready to implement this, you don't have to start from scratch. You can point your browsers directly to istartfromzero.com to download a unified deployment blueprint. This free package includes the custom proxy failover scripts you need to navigate the Cloudflare maze, the exact anti-hallucination pipelines we just discussed, and pricing calculators to model your own unit economics. It treats network access and epistemological validation with equal weight, giving you the exact tools you need. Thanks so much for joining me for this explainer on the truth of tech. I want to leave you with one final hard-hitting question to consider as you architect your next system. What is the greater existential threat to your project? Are you more afraid of waking up to a silent, catastrophic $1,420 infrastructure invoice? Or are you more afraid of confidently handing your sales team a database filled with entirely fake leads? Think about it.